We are going to see now a simple system that will allow us to explain what the transfer function is. The transfer function is a relationship between an output and an input. So in this particular case, we need to define what the input and the output is and find out that relationship. So let's see how that works. Okay. So in here we're gonna say the input here, we're gonna define the input, and then we're gonna define what the output is. Okay. So let's change it to another color here. The input in this case is the voltage is the input. Yeah. And we're going to say that the output in this case is V sub C. I am going to say we choose what the output, what the output needs to be. Okay. Now, you see in here, let's touch on what I mentioned to you a moment ago, the Laplace operator. Or Laplace transform. The Laplace operator, it says that if you have the operator of the derivative dt or the derivative of something, if you have it like this, this is equal to the operator s, or if you have d dx, or this could be d dt. It's actually d dt is the let's just make it, let's put the letter t in here. Capcom is not picking up my eraser. And right there, this, and then I need to pick up this one. So ddt is s. Yeah. So it follows that if you have dx dt, this should be equal to s times x of s, like this. So it transforms the time domain derivative into a s domain. So this, we're gonna call it the time domain. So that's in here, and this is, we're gonna call it the s domain. Okay. So what we need to do is to apply this operation to the differential equations of the system. Following this concept, if you have d dt of this, in other words dx dt like this is going to be s times s x of s, yeah, or equal to s squared times x of s. Yeah, these are the two things that we need to opt for our purposes. So let's look at the differential equations of the system. Let's call it differential equation All right. So how do we write the differential equations for this? We say that the voltage is equal to I times R plus 1 over C, the integral of I dt, right? That's what the voltage V sub C is. And then you have plus, this is S times di dt, no, L times di dt, sorry. This is well corrected here. So this is L times di dt. So this is the voltage of the resistor, voltage of the capacitor. This is voltage of the inductor. Notice this thing here, this equation here. This is the output. And we can write it down in here that this is 1 over C times the integral of I dt. Yeah? If the derivative is measured this way, the integral, which is the opposite of this, the integral dt is equal to 1 over s. Okay? So, okay, so we have this in here. We can say that the if we apply the Laplace transform to both of these, this would be well, let's go on. Before we do that, let's put it in terms of the charge, because this will be dq dt times R plus 1 over C. The integral is 1 over C times Q plus L times D square Q dt squared. So this is the same equation as this, but in terms of Q. If you apply the Laplace transform to this, you could say apply the Laplace transform. Okay, so we're going to apply the Laplace transform. So this is going to be voltage of S is equal to S times R times Q of S plus 1 over C times Q of S like this plus L times S squared times Q of S. So if we could write it down that this is V of S like this, is parenthesis, this could be like L, no, times S squared plus S times R plus 1 over C multiplied by Q of S like this, right? So it follows from this relationship that the relationship of the output, which in this case would be Q of S, related to the input V of S, is going to be equal to 1 over Ls squared plus Rs plus 1 over C. And this relationship that you see in there, this ratio between the output and this relationship to the input. Okay, this is called the transfer function. So if you write it down in here, this is called the transfer function. It follows that you can always find out what the output is. If you could write it like this: Q of S is the output, is equal to the transfer function multiplied by the input. See? And then, of course, it follows in the case of the piezoelectric transformation. If we have the input, we should know the output, you see, if we know the transfer function. So I think that this is, we could just do a very simple example using MATLAB with this transfer function, and you'll see how you can actually use this. So let's just, I didn't mean to minimize it this much, but let's just try it here. Okay, let's just keep it like this for now. I'm just interested on the transfer function. I want to move it and it doesn't like me moving the window. But okay, if that's the case, I'll just run MATLAB and I'll show you real quick what we can do with this. I think you will like this, because right now, if I have the system, and I told you that if we know the transfer function and we know the input, then we should know the output. So we could make a test with an input. There you go. We could give it a step input and find out what it does. As long as MATLAB cooperates with me in a moment, we'll do this real quick. So as soon as this comes up, we can do the test. But the concept is what I'm interested on. Is you have in this case the output and this the input. The relationship between the output and the input is called the transfer function. Now let me show you how you could actually enter this in MATLAB. As soon as this comes up, we will do this. If we can only hurry it up a little more, it will come up, but it takes a few moments. The idea here is, so as you can see ahead of time, what I'm doing is I'm going to give it the numerator description. I'm going to give the denominator description. And after that, I should have the transfer function like this. And then, of course, I want to do like a step input to do this. So, there we go. So we have MATLAB on in here. And we're going to say, I'm going to put it clear in here of anything. I'm going to say the numerator of this. See, this is a yeah. And here I'm going to say the numerator of this thing is just 1. So I put that in here. The denominator of this thing is a polynomial that has this coefficient, let's say, for s squared, let's say 2, for r, let's say 1, and for c is 1 over 30, let's say, and then close the parentheses, and we say, okay, this is it. And then I am going to say the transfer function g is equal to the transfer function of the numerator and the denominator. And watch what happens. See, the computer is going to give me the transfer function like I have it over here, see? And then I could just say very nicely and say, do the step input for test the voltage is a step input, and please give me the answer. And then it goes and does the calculations, thinks about it for a little bit, and it should give us the step input, and there it is. See? So we will analyze this in more detail later with other examples.